Dear students, Assalamu alaikum. Today we are going to discuss class 11th, chapter number 2. The name of the chapter is Atomic Structure. Last time we discussed about the discovery of neutron, then we discussed the properties of neutron. After that, there are two topics. One is the Rutherford atomic model, while the next is the Bohr atomic model. Both of these two videos are already I have uploaded in the 9th class. The same topics are here, so you must consult those videos. If you go to our channel, which is after my name, so you can also visit those videos. So I'm not going to discuss those topics, that's Rutherford atomic model and Bohr atomic model. I have already uploaded these videos in case of 9th class, so you can visit it. Okay, so today I am going to discuss the applications of Bohr atomic model. In your book there are two applications of Bohr atomic model. So we will discuss the first application of Bohr atomic model, which is my topic today: derivation of radius of an orbit of an atom. So how to calculate radius? You know what's a radius? Radius is the distance between the nucleus and the edge of an orbit, or to where the electron can be found. So this distance is called radius. Let's consider or remember that Bohr atomic model is only applicable to hydrogen and hydrogen-like ions, which have only one electron system. So if two electrons are there, then definitely they will repel each other. But we are only concerned with the force of attraction between the nucleus and the electron. So this will create problems. So that's why Bohr atomic model is only confined to single electron atoms or ions. For example, hydrogen has only one electron, so it's a single electron system. Similarly, helium has two electrons, but if we remove one electron, we will form He plus 1. That is a single electron system. Similarly, lithium has 3 electrons. If we remove 2 electrons from lithium, we will get Li plus 2. So 1 electron will left in lithium ion. So Li plus 2 is the 1 electron system. So Bohr atomic model is applicable. Similarly, beryllium has 4 electrons. So if we remove 3 electrons from beryllium, 1 electron will left. So Be plus 3. This also obey Bohr atomic model, and Bohr atomic model is applicable to Be plus 3. So Bohr atomic model is only applicable to hydrogen atom and hydrogen-like ions. So I have considered here the hydrogen atom. Let's say this is the hydrogen atom. This is its nucleus. If you see, in nucleus I have written Ze plus. E plus, there is only one proton in the nucleus of hydrogen atom. E plus is the charge on proton. E plus is the charge on proton. While the Z is the atomic number. For example, in helium the atomic number will be 2, in hydrogen it is 1, in lithium it will be 3, and in beryllium the atomic number will be 4. So you have to put the values of those Z. Z represents atomic number which changes from atom to atom. That's why, while E minus, this black E minus represents the charge on electron. So E minus is the charge on electron, E plus is the charge on proton, while Z is the atomic number. Atomic number represents the number of protons. You know, the nucleus carry positive charge due to the presence of proton. There is no neutron in hydrogen atom. So nucleus carry positive charge and electron carry negative charge. So there is a force of attraction between these two. You know the force of attraction between the oppositely charged ions is called electrostatic forces of attraction. It is also called Coulombic forces of attraction. You know, for a body to revolve in a circular path, just like the electron around the nucleus, it revolves in a circular path or shell or orbit. A force is necessary to compel this electron to follow a circular path, and that force is called centripetal force. Centripetal force compels a body to move or to reside in a circular path. So here the electrostatic force, the force of attraction between the nucleus and electron, it provides the necessary centripetal force. Dear students, which I am going to discuss, you have to write it while attempting such a question. I have just taken the mathematics, but you have to start from hydrogen atom, hydrogen-like ions. Let's say there is an electron E which is revolving around the nucleus. The nucleus carry charge Ze plus. E plus is the charge on proton and Z is the atomic number. The radius is R. Electron has mass equal to m and velocity equal to v. So this v represents the velocity of electron, m represents the mass of electron, E minus represents the charge on electron, R is the radius of this orbit. So in order to move in a circular path, for electron, centripetal force is required, and here the force of attraction between the nucleus and electron, which is the electrostatic force, this provides necessary centripetal force. So electrostatic force or Coulombic force provides centripetal force for the revolution of electron around the nucleus. You know, if this is the centripetal force, there must also be a force which is opposite in direction but equal to magnitude of centripetal force, which is called centrifugal force. So this red arrow indicates the centrifugal force. This centrifugal force is equal to centripetal force in magnitude, but their directions are opposite. So as we have two charged bodies, that is the proton and electron, so and there is a force of attraction between them, so I can apply Coulomb's law here. You know the statement you would have studied the Coulomb's law. So according to Coulomb's law, the force of attraction, the electrostatic force of attraction, is directly proportional to the quantity of charges on each charge and inversely proportional to the square of the distance between them. So according to if we remove the proportionality sign, we have to put a constant which is k here. So the equation becomes F electrostatic becomes equal to K Q1 Q2 divided by R square. K is the proportionality constant, and remember that its value is 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. You know, if two charges are present, the medium in between these two charges determines the quantity or the force of attraction or repulsion between them. Here we have considered just a space. So E naught represents the permittivity of free space. If air was here or water was here or some plastic or other material was here, then the value of E naught epsilon naught will be different. But for free space, the value of permittivity of free space E naught is equal to 8.84 into 10 to the raised power minus 12 Coulomb square per joule per meter. So remember this value. It may be one of your multiple choice question, that what's the value of permittivity of the free space, that is epsilon naught. So it is given in your book. So for an electron to revolve smoothly around the nucleus, the centripetal force must be equal to centrifugal force. So these two forces must be equal in magnitude but opposite in direction. So I have mentioned here, here the Q1 is the charge on the nucleus and my Q2 is the charge on electron. So I am going to replace Q1, Q2 by Ze plus and E minus. Ze plus is the charge on the nucleus and E minus is the charge on electron. So as both the forces are equal, the electrostatic Coulombic force, or you can also write centripetal force, equal to centrifugal force. So these forces are equal in magnitude but they are opposite in direction, and we know if I replace K1, Q2 by Ze plus and E minus and also put the value of constant, which is the 4 pi epsilon naught, then the electrostatic forces of attraction or Coulombic force will become equal to Ze plus E minus 4 pi epsilon naught r square. And you know centrifugal and centripetal force both have values equal to mv square by r. M is the mass of electron, v is the velocity, r is the radius of an orbit. Again here r is the radius of an orbit, pi is the constant, you know it's used for a circle. So here by comparing these two, if I cancel this r with the r square means r into r, there are two r, so one r is cancelled with this r. So we are left with Ze square is equal to mu square by 4 pi epsilon naught r. Now by cross multiplication we get the mu square and these two are multiplied with each other, and here is 1, so Ze square is multiplied with 1. So we get Ze square is equal to mu square 4 pi epsilon naught r. Rearrange this equation for r. So retain the r here and transfer this term here. So we will get r is equal to Ze square 4 pi epsilon naught mv square. So look at this equation. This is very important equation, and also I have marked this equation is equation A because this equation will be used later on and when we calculate the energy of electron, which is our next topic. So for time being I am here. Look at this equation. Z is constant, E is constant, Z is the atomic number, it is constant for an atom. E is the charge on electron, 4 is constant, pi is constant, epsilon naught is a constant, it has a particular value. Mass of electron is constant. But V square, which is the velocity, it changes from orbit to orbit. And the velocity of electron also depends upon temperature. So the velocity of electron may change fractionally in a fraction of second. So it's impossible to determine the absolute value of an electron. So if we need to determine the radius of an orbit, we will need atomic number, charge on the electron, value of pi, value of epsilon naught, value of m, all these are given, but the absolute value of velocity can never be determined because it changes many times in a single second. So we have to eliminate this v. We have to put some other value instead of this velocity v. So in order to eliminate this v, you have to write this, whatever I have mentioned, I said you have to write this in your paper. Okay, now we are going to eliminate this velocity term because velocity of electron may change. It depends upon temperature. It may change many times in a single second. So, and from orbit to orbit the velocity changes. So that's why I have to eliminate this term. How to eliminate this term? We use the fourth postulate of the Bohr atomic model, which is the angular momentum. You know, according to the Bohr postulate, the electron can only revolve in which the angular momentum of electron mvr is the integral multiple of the factor h by 2 pi. So n is the number of shell, h is Planck's constant, pi is used for this for a circular nature or circular path of the orbit, m is the mass of electron, v is velocity, r is this. Rearrange this equation for v. We get v is equal to mr, both comes here, they are transferred here. So v is equal to nh by 2 pi mr. But here is v. But in this equation 1 we had v square. So in order to equalize this v with the v square, we are going to square both sides. So squaring both sides will turn v into v square. So v square becomes equal to n square h square, square of 2 is 4, pi square m square r square. Now put the value of v square from this equation into equation 1. We will get something like this. For example, look at here, r z e square 4 pi epsilon naught m, 4 pi epsilon naught m, but instead of v square I have put this value, the value of v square here. You know, the denominator of denominator, it goes up to the numerator, so this term goes upward, so it come here and cancel the like terms. 4 is cancelled with 4, pi square with pi, so 1 pi left here, m with m square, 1 m is cancelled with this m, so we are left, and you know, this r square is cancelled with this r, so 1 is left here, okay, and we get this equation. Now by cross multiplication, you know, there is 1 under 1, 1 by 1, so by cross multiplication we get this term multiplied by 1 equal to this, and 1 multiplied by this equal to this term. Now rearrange this equation for r, so transfer the z e square pi m to here into the denominator, so the r, and retain the r, so the r will become equal to epsilon naught n square s square z e square m pi or pi m, whatever you call it. Okay, so we are here. Now we know the atomic number Z of our hydrogen atom is 1. So for hydrogen atom Z is equal to 1. So put 1 instead of Z, we will, this equation will be reduced to this. You know, here epsilon naught is the permittivity of free space, which is a constant. Planck's H is the Planck's constant, which is constant. E is constant, M is constant, pi is a constant, which is particular. All these have particular values except N. N is the number of shell. For the first shell, it is N is equal to 1. For second, N is equal to 2. So I have retained N square, and all these constant, instead of all these constant, I have written A naught. A naught is equal to all these constants. Epsilon naught, s square, e square, m pi. So instead of all these constants, I have written just A naught. And if we put the values of these constants, and after calculation, we will get that, we will find that A naught is mathematically equal to 0.529 into 10 to the raised power minus 10. And you know 10 to the raised power minus 10 is equal to 1 angstrom. A naught angstrom. So A naught is equal to 0.29 angstrom. Put this value here instead of A naught. We will get the radius of our orbit L square and n to 0.529 angstrom. For radius of nth orbit, then you must write Rn, which will have value this equal to this. If you go to your book, you will see that if we want to determine the radius of the first orbit, so you have to write R1 and put n is equal to 1. So you will get 0.529 angstrom for the first orbit of hydrogen atom. Similarly, if you go for the second orbit, then put n is equal to 2, and for the third orbit of hydrogen atom, you have to put n is equal to 3, and so on. So in this way, you can determine the radii of the various orbits of the hydrogen atom, which is given in your book. You can consult it, and remember that as soon as you move from n is equal to 1, that is the first shell, to second shell, third shell, fourth shell, the radius of an orbit progressively increases. Okay, so so remember these points, and also always remember this equation here. The r and v square, they are inversely related to each other. So this means that velocity of electron decreases with the increase in the radius of an orbit. This means in first shell, the electrons revolves with a high speed, and the second shell with comparatively lower speed, lower velocity, and third shell then its velocity is furthermore reduced. So as we increase the radius of an orbit, in other words, if we move to the higher orbits, so the velocity of electron will progressively decrease. So this is very important for you can say for multiple choice for your competitive exam, that for example various shells are given that in which of the following orbits the electron will have the lowest velocity or speed. So this was something about the derivation of the radius of an orbit. Check it, and if you have some concerns or questions, you can call me, you can ask. I thank you all. Students, now we are proceeding towards our next topic. After the radius of an orbit, you will see, if you go to the next page, you will see there will be a topic, derivation of energy of an orbit. First, we calculated the radius of an orbit. That was one of the application of the Bohr atomic model. Now we are proceeding towards the second application of the Bohr atomic model, which is derivation of the energy of an orbit. It is present in the page 32. So remember that actually this is the energy of an orbit, but actually this is the energy of electron in an orbit. So you know, electron is not stationary, it's continuously revolving around the nucleus according to the Bohr atomic model in fixed orbit. So as electron is moving, and you know the energy carried by the moving body is the kinetic energy. So the energy of electron is twofold. I mean, there are two types of energy of electron. One is the kinetic energy, the other is the potential energy. And potential energy of the kinetic energy of electron is due to its motion, while the potential energy of electron is due to the attraction towards nucleus. As we know, electron carry negative charge, the nucleus carry positive charge, so electron is continuously attracted by the nucleus. So if electron is revolving, if you consider the electron as a stone and the force of attraction is thread, if you bind a stone with thread and you revolve it in a circular path, and at any point if the thread breaks, the stone will go in a particular direction. That stone can hit a glass and can break it. It can injure a person. This means when the stone was revolving in air and it had a hidden energy, and that energy is only shown when that thread breaks. Okay, so the stone will go in a particular direction and it can hit, it can do some work. So for the same reason, when electron is revolving around the nucleus, it is continuously attracted by the nucleus. So when electron is revolving, it is attracted by the nucleus, so it has some hidden energy which is called potential energy, and potential energy is due to the attraction from the nucleus. So if we break this force of attraction, the electron will go in a straight line according to its velocity, and it will do some work. This means that while revolving around the nucleus, electron had a hidden energy which is called potential energy. So total energy of electron, E total, is the sum of the kinetic energy and potential energy. We know it's a well-known equation that kinetic energy is equal to half mv square, and we had calculated, we also have calculated the you can calculate, you can also guess about this. The potential energy of electron is given by minus Ze square 4 pi epsilon naught r, and I will discuss that how it is derived. We will discuss this in class, but for time being, just remember that potential energy is equal to minus Ze square by 4 pi epsilon naught r. Plus into minus is equal to minus, inserting or multiplying these two, we will get this term. So here we get E total is equal to half mv square minus Z square 4 pi epsilon naught r. Now we have to go back towards our previous topic, which is the radius of an orbit, and there from I told you about in equation A, I also told you that this equation, that equation will be used later on. So now we are going to use that equation A. Okay, so and equation A was actually the value of mv square. So put the value of mv square here, mv square, put the value of this mv square from equation A into equation 1. So putting the values of mv square into this equation, and that value was equal to ze square 4 pi epsilon naught r. You know, here is ze square minus ze square 4 pi epsilon naught r, 4 pi epsilon naught r. So these two terms are common. So taking out ze square 4 pi epsilon naught is common. So when we take out these two terms is common, we will get this, and here we get only 1 by 2 is remaining, and here 1 is remaining, but we know the denominator of 1 is of any number is 1, so we get 1 by 2 minus 1, and when we subtract the half from 1 or 1 by 2 from 1, we always get what? Minus half, and multiply this minus half with this. So 4 2s are 8, and this minus comes here. So here is minus, here is minus. Okay, so put minus sign here. So the energy of electron, total energy of electron is now represented by the n. N is the number of shell. So for energy of first orbit, you can write E1, energy of the second orbit, you can write E2. So in order to calculate the energy of electron, we need atomic number, which is already known. E is the charge of electron, which is known to us. 8 pi has some value, we know it. Epsilon naught, it is a constant, we have discussed its numerical value, but we need the value of r. So for each orbit, in order to calculate its energy, we will need the radius, and we have derived an equation for radius. So we will put the value of that r here. So we know that r is equal to that this is the value of r, and we have put it instead of this r. So here is ze square 8 pi epsilon naught, 8 pi epsilon naught, and instead of r, we have put the value of r from our previous topic, which was the calculation of the radius of an orbit. So from that topic, we have picked up the value of r, and we put that value here. When you put it again, here is the denominator of denominator, so it goes at the numerator. So again, when we transfer it and cancel out the likewise terms, the like terms cancelled out, pi is cancelled with pi, z multiplied by z is equal to z square is equal to e4, m's come here, and 8 epsilon naught into epsilon naught, it gives epsilon naught square. Similarly, n square, s square, n square, s square. But we know that here z is the atomic number, and actually the Bohr atomic model is only for hydrogen and hydrogen-like ions. So for a hydrogen atom, the z is equal to 1, atomic number is equal to 1. So this z becomes 1, and 1 square gives us the value of 1. So this term is eliminated. So we are left only with the En is equal to E4 m 8 epsilon naught square, n square, s square. So now we know all these are constants except n, which is the number of shell. So taking out at one side all the constants, and n is left here, so and I have transferred all the constants towards the left side. So we will get E4 m8 epsilon naught square s square. Putting the values of these constants, and after calculation we will find that if we put the values of these constants and after calculation, we will get that the answer will be 2.7178 and to 10 to the raised power minus 18 joules. Joule is the unit of energy. So put this value here and instead of this term we will get the minus 2. So sorry, here in front of each value here is a minus sign, so please put minus sign here. Okay, so En is equal to minus 2.178 into 10 to the raised power minus 18 into 1 by n square. If you want to determine the value of energy of any orbit, for example first orbit, so put E1 and 1 instead of n, and after calculation you will get this value. Similarly, if you want to determine the value of the energy of the second orbit, write E2 here and 2 square, so it will be 4, so divide this term by 4. Similarly, if you want to determine the energy of the third orbit, so put E3 and 3 square, so 9, so divide this term by 9, you will get the corresponding energy. So now they have considered this term equal to K, which is constant. So this equation will become just like this. En is equal to minus K by n square. So now look at this. En is inversely related, but here is a minus sign. So in order to remove the minus sign, we have to invert this equation. So by inverting this equation, we will get n square by k. Okay, in order to eliminate or in order to remove this minus sign, we have to invert the right hand side term. When we invert this term, we will get n square by k with positive sign. Then you will be able to see that there will be a direct relation between the energy and n square. So this means that greater is the value of n for an orbit, greater will be its energy. This means that when the value of n increases, I mean if the energy of first orbit is less, the energy of second orbit is greater than the first orbit. Similarly, the energy of the third orbit is greater than the second and first. So as we move towards the higher orbits, the energy of the orbit or electron in an orbit correspondingly increases. Okay, so and here the negative sign indicates that there is decrease in the energy of electron due to the attraction between the nucleus and electron. So the negative sign actually indicates the decrease in energy of the system. Why energy is decreased? Because there is attraction between the nucleus and electron, and electron, when there is attraction, energy is released, and due to the release of energy there will be a decrease of energy, and that decrease is shown by the negative sign. So in order to determine if you want to determine the value of energy in joules, you will use this equation, and if you want to determine the value of energy of an orbit or electron in kilojoules per mole, then you have to use this equation, and it will give you the energy of an orbit or electron in an orbit in kilojoules per mole. So just put the value of your shell, which is n, and after calculation you can get the it must be noted that as we move towards higher orbits, the energy difference between the two shells correspondingly decreases. So the difference between the difference of energy between the first and second orbit is the greatest, and then between the energy difference between the second and third is comparatively less, and similarly between the third and fourth, again this is much more lower than the second and third, and similarly the energy difference between the fourth and fifth shell is lower than the third and fourth. So as we move towards the higher orbits, the difference of energy between any two levels progressively decreases. So this must be noted as the energy in a separate orbit increases, but the difference of energy between the two orbits progressively decreases. You must remember it. So dear student, this was something about the energy of an orbit. You must calculate it. Also write all these calculations and my discussion which whatever I have discussed. Please write the statements as well, not only just follow the mathematics. Also whatever step you are going to do, so write in words, okay, and then show it to me. So you have to write and practice out these two questions. These are very important from examination point of view. As far as this chapter 2 is concerned, these two questions are very important. You can see the past papers. These are very important. I thank you all.